Question number 22. Jump past question 2001. In the diagram below, the current X, we can see the symbol for current, capital I, the current X. When you see this type of question, face it with confidence. Recall, we already have a formula that guides flow of current in a circuit. I is equal to V over R, Ohm's law. Ohm's law. To find the current, we'll be using V over R. Then observe your circuits. These are voltage, the source of power. Voltage, 6 volts. We'll substitute for V. Then coming to resistance, we'll get confused. We have plenty resistance in the circuit diagram. There are many resistance. Okay, you have to recall that there are two ways of arranging resistors in a circuit diagram. We have the series connection and we have the parallel connection. Okay, this is parallel connection. This is what we call parallel. Yeah, 10 ohm resistor and 5 ohm resistor are arranged in parallel connection. Whereas 3 and 1 are in series. 3 and 1 are in series. Then following Ohm's law, we just need a single resistance to finish up the solving. Okay, let's push. Current is equal to, recall, our voltage is 6 divided by our resistance. We are here to know the total resistance. To get the total current in the circuit, we need the total voltage. You also be needing the total resistance. Here we have plenty resistance. So we have to resolve on to get a single resistance called effective or total resistance. Okay, let's push ahead. Then observe this parallel connection. We need to do some justice there. What do? We need to resolve this connection. So we have a single resistor there. We will resolve this to get a single resistor that will reflect both 10 and 5. So that single resistor will now be in series with every other resistor. This is parallel. We'll resolve it into one so that we now have series connection in the entire circuit so as to get that effective resistance. Then recall. Then to get that RT, let's start with resolving parallel connection. For parallel connection, we have a formula that says 1 over RT is equal to 1 over R1 plus 1 over R2. This is one for finding resistors and parallel connection. So let's flow. We'll come over here. Then 1 over RT is equal to, we have 10 and 5 in parallel connection. So we 1 over 10 plus 1 over 5. Either can come first. We don't have issue with that. Okay. Then 1 over RT is equal to, LCM of 10 and 5 is 10. 10 divides 10, 1 times 1, 1, plus 10 divided by 5, 2. 2 times 1, 2. We'll be having 3 over 10. Recall, we are looking for RT and not 1 over RT. Therefore, 1 over RT is equal to 3 over 10. Therefore, RT over 1 will be, notice what I'm doing, I'm reciprocating. Since RT is coming up and 1 is going down, 10 will go up and 3 will come down. We'll be having 10 over 3 ohms. That is exactly what we're looking for. 10 over 3 ohms. We've gotten the total resistance in parallel connection, 10 over 3 ohms. Then we'll be bouncing back to our diagram. We'll change that diagram. This is now the new diagram. And the resistor here X. 10 over 3 ohms. You cannot believe with me that every resistor there is now in series connection. They all have one current flowing through them. There is no junction again for current to divide. So they now have the same current. So the formula will change. Then for series series connection, we'll be having RT is equal to R1 plus R2 plus R3. We'll have 3 resistors. Then we'll push ahead. RT is equal to, my R1 is 1 plus 3 plus 10 over 3. This over 1 over 1. Then RT is equal to, let's find the LCM. The LCM of 113 is 3. 3 divided by 1. 3. 3 times 1, 3. Plus 3 divided by 1, 3. 3 times 3, 9. Plus 3 divided by 3, 1. 1 times 10, 10. Therefore, RT is equal to, add all the numerators. We'll be having 22 all over 3. All this resistance, all the resistance here now have a single meaning. So the circuit diagram will change. We now have a single resistor, which is 22 over 3 ohms. Then the current, I. So we're good to go now. We can now bounce back to our initial process, the starting, where we say that the total current is the total voltage over the total resistance. This is the total resistance. Therefore, we'll continue. Therefore, to get the total current, I is equal to 6 divided by our total resistance. The single resistance is 22 over 3. This over 1. To continue from here, okay, I is equal to 6 over 1 times reciprocate. Since we change division sign to multiplication sign, 3 over 22 equals 6 times 3, 18 over 22 equals, okay, observe keenly. 2 divide 18, we'll be having 9. 2 divide 22, we'll be having 11. Therefore, the current running in the circuit is 9 over 11 amps or ampere. 9 over 11 amperes. Going back to our option, we can observe that the correct option there is option B, 9 over 11 A, which stands for ampere. Thank you. Relax as we continue.